All right, let's do this. Welcome everyone. It's a session right after lunch, so that's usually when everyone doses off a little bit, so I hope that's not going to be the case in this session. For those of you who are here to learn about building microservices within an IDE, I'm afraid I will have to disappoint you. If you are here to learn about how at JetBrains we have built Rider using a microservices technique, then you're in the right place and welcome. So I'm Maarten, I work at JetBrains and basically on Resharper and Rider and so on, and I really want to give you some insights into how we have built Rider and why we have built it the way we have built it over the past years. So just a quick show of hands. Any one of you is currently using Rider? All right, a lot of hands, thank you. For those who haven't ever seen Rider before, I'll give you a quick demo of what it looks like. The idea is not to go too deep into what it can do, but just to give you a feel of what it looks like and what is there. So we have on the left, we have a solution explorer. Obviously, you can select files, you can navigate to wherever you want to navigate. So let's navigate to our iLogger interface. We can go back and forth, we can write code, we get inspections and so on. We have version control, a NuGet tool window, we have a database connection so you can look at your tables, you can look at all of the different columns that are in there and so on. But all of this is built in two technologies, .NET and the JVM, so Java and Kotlin as a language. And it's really fluent, it works well, and I want to quickly show you how it's built. So Rider is a cross-platform full-stack .NET IDE, so it does a lot of things. It does WinForms, it does ASP.NET MVC, it does TypeScript, HTML, Unity, WinForms, whatever you want it to do on full.NET, on Mono, on .NET Core, pretty much every version of .NET Core. It's lightweight and fast, but it is a complete IDE, so you get all of the inspections, you get all of the code completion and refactorings and so on that are in there. All of that is in there because Resharper is actually in there. So for those of you who are using Resharper, Rider is in fact Resharper with a UI on top. That is not Visual Studio. There's lots of plugins available as well because the front end we have built is really IntelliJ, and all of those plugins are available in Rider as well. And for those of you who want to try it, there's a trial available on the websites. Now, just want to give you a quick view of the history of JetBrains as a company. So we were founded in 2000 in Prague, and we started off with one project or one product called IntelliJ Renamer. Anyone who has ever used that thing before? Because if you have, I would love to get my hands on an actual binary of that thing to just look at what it looks like. Because that thing was basically just one form that allowed you to point to a file in your code base, and you could rename that file and it would figure out what all the references were and update all that. So basically the rename refactoring as a standalone tool. In 2001 we decided, okay, maybe that standalone tool is not enough, maybe we have to build a full IDE, and that became IntelliJ. Now you see, 3 years after IntelliJ, we also started building Resharper, so a tool for .NET. The reason for that is really Eclipse. In 2004, Eclipse came about as well as a competitor to IntelliJ as a Java IDE. And we decided, okay, maybe we need something else that is not JVM, that is not Java, and maybe we want to have an actual .NET thing as well. Fast forward to today, we have more than 20 IDEs, but all of them are roughly built on top of IntelliJ. So all of that history is there, and we've built on top of that history. Now, anyone has ever used Resharper in their early days? Anyone seen this one? Yeah, a couple of people apparently. So this was Resharper. In fact, when we first started building Resharper, we weren't yet sure whether, first of all, Visual Studio was going to take off, whether we should build a plugin to Visual Studio or build our own IDE. So we basically bet on two horses, and we built it both as a plugin as well as a standalone IDE. So this is Resharper, I think version 2.0, because 1.0 really never saw the light of day. But we built this entire thing in WinForms. So you see a nice solution explorer on the left. You see all of the classes and namespaces and so on in that .NET assembly. You see the code. You can navigate to code. There's rich in-editor summaries and information about the code that you are writing. There's find usages at the bottom, so you could actually navigate through that code base as well. So a lot of the things that you see in Rider today, that you see in Visual Studio and Resharper today, are still based on what we built in this Resharper 2.0. Now that Resharper IDE in the end, never really saw the light of day apart from some preview versions, because we thought, okay, maybe building a plugin to Visual Studio is probably the right way to go with Resharper. So we halted the project of building that standalone IDE for .NET. But several concepts and part of the architecture remained. So the find usages window that you saw in there, that's still roughly the same code base, or at least roughly the same techniques as the one that we currently have in Resharper. Also, we kept the fact that we bet on two horses so that we could build a plugin as well as a standalone IDE. We kept that around, and we basically made that a competitive strength for us, because we could now plug in to Visual Studio 2010, still today, 2013, 2015, and so on, because we had that abstraction between having a plugin as well as having a full IDE. So we wrote the necessary things to make that abstract and work. We also have Resharper command line tools. So Resharper, if you want to use this on your build server, for example, and run a code cleanup from the command line, you can do that. That's the exact same engine, but it's just a different interface on top of that Resharper core that we have in there. So it hasn't gone to waste, but we kept a lot of the techniques in there that are available. Now, we have booths at conferences. I even think this is NDC London. And at booths, a lot of people over the past years came to us and asked, when will JetBrains come with their own .NET IDE, so that I can actually use a JetBrains IDE instead of having to have this plugin into Visual Studio. 4 years ago we did, and then everyone said, why did you build your own IDE? You're nuts. But still we did. The first reason was people were asking for it. Second reason was Roslyn came about, Visual Studio became bigger and bigger, and Visual Studio is a 32-bit process, and we have some constraints there. Even if you have 64 gigabytes of RAM in your machine, you only basically get like 2 gigabytes of memory out of Visual Studio, and that's all we have. Roslyn is in there, Visual Studio is in there, we are in there, and roughly everyone is competing for that limited amount of memory. So we decided, okay, let's see if we can take Resharper out of that thing, use it as a 64-bit process, and basically have our own engine running as a faster thing. So that's one of the reasons. Also, a lot of changes in Visual Studio started impacting Resharper. I think at some point lightweight solution load was introduced, and the global.json file and so on. And those were pretty invasive changes, and we had to respond to those even though we didn't really know whether that was going to have some take-up or not. So we had to adapt Resharper to those things as well, and we wanted to sort of isolate ourselves from a lot of changes there. Also, .NET Core happened. We saw that .NET Core apparently ran on Linux and on Mac OS and so on. And the only alternative back then was probably monodevelop. I don't know if anyone has used it at that time. It's a proper IDE, but it's not Resharper, it's not Visual Studio as such. So we decided, okay, maybe there's a space for us with a separate IDE that runs cross-platform, that runs on Linux, Mac, and Windows. Now, the problem is, if you want to run cross-platform, it's fairly easy if you have like that backend that runs as a command line tool and you want to port that to .NET Core and have it run on Linux or Mac OS X or whatever. You could use Mono or .NET Core or whatever you want. But you also need a UI toolkit. If we have Resharper and you have a rename refactoring where you see a UI where you can enter a new name and refactor whatever you want to refactor there, you need UI elements. You need to visualize whatever you want to do there in your IDE. So we thought, okay, well, what's the cross-platform story that we can do in terms of UI? Because Resharper is built mostly in WinForms and WPF, and that's not really cross-platform. So we looked at, how could we maybe rebuild our UI? Could we use WinForms on Mono maybe? Could we use JTQ Sharp, which compiles to Windows and to Linux and Mac, maybe Qt and so on. But we decided, okay, maybe this is not the best thing, because we would have to rebuild everything that is in Resharper in terms of UI, plus everything that consists that you want to have in a UI, in an IDE UI. So a solution explorer, an editor, and so on, which we were currently reusing from Visual Studio, right? So we started thinking, and we thought, okay, we have this IDE IntelliJ, and all of our other IDEs are built on top of IntelliJ, which is the platform which has an editor and so on. So why not maybe reuse that to have it work with Resharper? So we decided, okay, let's look into our own IntelliJ platform, which is that shared core between all of the IDEs we have, because that thing already has a UI, is cross-platform because it's written on the JVM. It has a project view, it has the source control plugin, it has a terminal, it has plugin systems and so on. And we have been successfully building other IDEs on top of that thing, and others have as well. If you use Android Studio, for example, that thing is built on top of the IntelliJ platform open source project that exists. I know there's a Perl IDE as well around, which is also built on top of IntelliJ, and if you want to build your own IDE, you can actually do that if you want. So we thought, okay, let's reuse this. It's cross-platform, runs on the JVM, so let's look into that. Now, IntelliJ has all those standard components like an editor and the view on a project and the file system and so on, but it's JVM, whereas Resharper, on the other hand, is everything that we have for .NET, but it's written in .NET. How could we marry that JVM process with that .NET process? How could we bring those two together? So we thought of some options. One option could be to maybe rewrite Resharper in Java so that we could plug it into IntelliJ and run it all as a JVM thing. We quickly decided that was probably not going to work because Resharper has been around for 15 years and you all know the big rewrite, it's never going to work. So we decided, okay, let's maybe not rewrite this thing in a different technology. Let's maybe look at an automatic conversion. I mean, C# looks a bit like Java. Maybe we can convert everything and automatically transpile into Java and do something there. We also thought that's pretty insane, so we decided not to go with that. Now, we look back and we have those command line tools for Resharper as well. So we thought, okay, what if we run Resharper as a process, headless, and have IntelliJ as a thin UI on top, communicating with that process and basically getting the information we want from Resharper and working with that Resharper process in there. So we thought, yeah, that's a good idea. We just need our own UI on top. And just need our own UI on top. It turned out to be more complex than we thought, but still we ventured on that avenue. So headless Resharper as a language server, which would be easy because it's all .NET. We could run it on .NET on Windows, and we could use Mono on Linux and Mac. No real constraints because it is Resharper. We could reuse everything, and we could have two projects based on one code base, which was Resharper, and then have IntelliJ as a thin UI on top. Now, the problem is IntelliJ really a thin UI? Because that is a real IDE. It powers Java developers, it powers Kotlin developers. We have PHP Storm, which powers PHP developers. It is an actual IDE. We have the concept of navigation in there. We have a concept of a solution structure in there as well. Resharper at the same time has similar concepts. We also have a solution structure in there. We have to know how everything in your project fits together, and basically both IntelliJ as well as Resharper, even though it's headless, are a full stack IDE or a full-blown IDE. We also started looking at the different features that are available on both of the sites, and there are cases where IntelliJ could do everything. If you use version control in Rider, that's pretty much all front end, no Resharper is involved there. There are cases where Resharper does everything. If you edit .NET code, if you edit C# or VB.NET or F#, that's probably going to be powered by Resharper because there's no real C# concepts in the IntelliJ front end. And there are cases where both IDEs may actually contribute to the same feature and make maybe a new feature even possible. So I'll give you a quick demo of a couple of things that are handled by one of both sides there. So obviously, if you write .NET, if you write any C# codes, you're working in Resharper. So all of the editing you do, all of the writing codes that you may do, if you write a public void foo and add that as a method, all of that is Resharper. You're writing this in Resharper, except for the editor itself, which is IntelliJ. But still, most of the logic here that you will see is powered by Resharper. If you go into an HTML file, all of that, it looks the same, the editor behaves the same and so on, but everything you do in here is powered by IntelliJ because IntelliJ already has HTML support, TypeScript support, JavaScript support, and so on, and we don't need Resharper for that, even though TypeScript is supported on the Resharper side as well, but it's not really needed there. We also have cases where we mix features. So if you look at a Razor page, for example, that's HTML mixed with some C# codes. In the beginning of Rider, we basically thought, okay, we have HTML editing and Razor editing in Resharper, so let's handle this entirely by Resharper. But then we thought, okay, then we're not on par in terms of features with the standard HTML editor. So we thought, okay, maybe the HTML in here should be powered by IntelliJ, whereas the .NET in here, the Razor syntax in there, should be powered by Resharper. So combine them in one editor. If you look at this one, that's a really interesting one. I have a database connection here, and I'm connected to a database, and I'm using .NET or Entity Framework Core and making use of raw SQL queries and writing SQL code there, basically passing in a string to Entity Framework. What happens is, if in that string I trigger completion, I get code completion based on that database connection I have. I can select and I get completion from the tables and the columns that I have in my database. All of the C# you see there is powered by Resharper, except for that tiny string that is in there, which is powered by IntelliJ in this case, because that feature has been there for 12 years or so, and we're basically reusing that just inside that string. So this is where both of the IDEs created a new feature together and make Rider better than what we could do in Resharper, for example. So there's a couple of cases there where, yeah, it's either one or the other, or both at the same time. Good. So we decided, okay, we have that JVM process, we have that .NET process. How do we make those two communicate with one another? I mean, it's not as simple as using shared memory or whatever, because it's two different ecosystems, even two different garbage collectors and two different platforms that are running. So we started looking at the features that we have in our IDEs. And one of the examples there is the contextual actions. You're editing code, all of a sudden you see this light bulb pop up and you press Alt-Enter and you see whatever options are available, like removing using statements or making a public method private and so on. You press Alt-Enter, and basically what happens in Rider is that the IntelliJ frontend will ask the current editor, give me your language and tell me what items I should display for this language. For building Rider, we could plug a virtual language proxy in there where the document could be like a proxy to Resharper, so that if we press Alt-Enter in that IntelliJ Java documents editor, we could get options from Resharper to see whatever is in there. And IntelliJ could then render them and show you all of the options that are available. But if you look at purely at the data that has to go between the two processes, that's actually a very simple structure. You have your document. A document has line numbers and column numbers, so we can find whatever character you want to show the notification on. So basically what we could do is pass a tree from one side to the other, a tree that holds which line, which column, and what's the name of the inspection to show here, and what should be the icon. Is it a warning or is it an error, for example? So the data structure is fairly easy. If we look at the actual inspection, so the squigglies you see while coding, that is also kind of a simple data structure. Again, we can have our IntelliJ ask the current document what its language is, have this virtual proxy towards our Resharper process, and have Resharper publish whatever inspections it wants to publish to IntelliJ. The data set there is also fairly easy. It's going to be a name of an inspection, it's going to be an icon, a severity again, maybe a tooltip, and maybe the text range where we want to show that squiggle. But important is we cannot do a remote procedure call there. If we have IntelliJ call into Resharper and wait for a response before we display anything in the IDE, that's not going to work, because Resharper may have to think about whatever is available in that context. Maybe it takes 400 milliseconds, maybe it takes close to a second to give you back that information. We don't want to have any lag in the editor. If you're writing code, you really want to write code, and you don't want to have to wait for the cursor to respond again because some process communication is happening on the back. So we couldn't do any RPC, but the data itself is fairly simple. When writing codes, that's a bidirectional thing. You're writing code in the editor in IntelliJ, but you're also kind of writing that code on the Resharper side, because Resharper can provide suggestions and can provide code completion and all of those things. So that's kind of a bidirectional thing. You're writing here, but Resharper may complete the statement and publish it back to IntelliJ, right? So that's something that happens at the same time. If you look at the data structure that has to go between those two processes, that's going to be easy. It's going to be a delta of how the document has changed between a number of keystrokes. If I write public and Resharper adds a method name or brackets or whatever, we can have a delta that says, okay, 2 brackets have been added and publish that vice versa between the 2 projects. So the data itself is again fairly easy. So we decided if the data types are not that complex, if we have those context actions as a tree and inspections as a set of names and so on, that's fairly simple. So if we can write something that is abstract enough to just pass around these simple messages, we can have everything work. If we make one inspection work and have some structure that makes an inspection in IDE work, we can make all of them work because it's going to be ideally the same abstraction and the same way of passing around that data between the 2 projects. Then we decided, okay, we know what data to pass. How are we going to pass this data between the 2 processes? Do we reuse the language server protocol? Anyone familiar with that one? Okay, 1, 2, yeah, a couple of people. The language server protocol, or LSP, is basically what VS Code is using. So what they do is they also have kind of a front end running, and whenever you want to invoke a code completion or you want to get inspections and so on, they also call into the language server for whatever language you're editing. Could be TypeScript, could be C#. And they publish that result back. So LSP in itself kind of has the same goal. It wants to build an IDE and make something happen between 2 processes, except for us, it wasn't really on par with the feature set we had in Resharper. We also have a lot of people asking about when is Resharper for VS Code going to happen. I don't think it's ever going to happen because right now LSP is too limited, and if we would build Resharper for VS Code, it would be a very limited Resharper edition there. So that's the reason why we are not doing that. But also because of that reason, we could not reuse the language server protocol. The only way to reuse the language server protocol is if we would add a number of customizations and extensions on top, which is possible in LSP. But if we have to build a lot of extensions on top, then we're kind of shoehorning everything into LSP. Maybe we should look into something else and make something that works better for our use case. So we started experimenting with our own REST-like protocol, basically have a web server running in Resharper and pass around some JSON or pass around some protobuf in a request-response style where both processes could make calls and get responses back and so on. We did that. That kind of worked, but it proved, one, slow, and also very clunky to work with. Our developers would have to always create like a controller, add attributes on top, and really they had to go through a lot of boilerplate to make that work in that type of protocol. Also, we realized that a lot of things are request response, but not everything, and you also have to shoehorn the bidirectional communication into a request response that works from Resharper to IntelliJ and from IntelliJ to Resharper. So we decided, okay, this works, but it's probably not the best because it's going to slow us down if we develop Rider like this. There's another interesting thing, and that is in conflict resolution. I mentioned that Resharper can do something and IntelliJ can do something. Imagine you are writing code and you invoke a refactoring, and it's a big code base, and Resharper has to think about that refactoring for a couple of seconds. And during that couple of seconds, you remove the file from the IntelliJ side. Which side wins? Is it the result of the refactoring, restoring essentially the file that you just deleted, or is the file gone? Also, that is not really in the language server protocol, so we needed something that also handled those cases where there's a delay between both ends processing something. We came to a realization, maybe request response style is not something we need. Our messages, our data is really simple, but request response, we have to do it both ways, and it doesn't really work for us. Also, if you do this request response style, there's a lot of data overhead. Like if you post this line of code has been deleted or added, we also have to post which solution this was in, what path this was in, a lot of state information has to go over the wire between the 2 sides in Rider. So we decided, okay, maybe if we can model this as a model view model type of approach, maybe this would work better. What if on both sides, both in IntelliJ as well as on the Resharper side, we could have a structure of concepts that we have in the IDE, so a project that has files, What if we could just call an add method on that collection and have that file appear on both sides of the protocol? What if we do a delete or we want to render an inspection, we could just post an inspection to a collection and it would appear on both sides? Well, visually on the IntelliJ side and invisibly in the out-of-process Resharper there. Both sides of the protocol could react to such changes. If we add a file, both could react and do something with whatever we are doing there. If we want to publish a warning, both sides could react to that. Still, that conflict resolution was also in there. That model view MVVM way of working looked promising, but there was still the idea of conflict resolution. If IntelliJ does something and you delete it while Resharper is refactoring, you don't want to have that. So we decided, okay, maybe we can introduce the concept of locking so that when you invoke a refactoring, you cannot delete a file. But again, we decided, okay, you want to have your flow as a developer. We don't want to really lock both sides until an operation finishes. We want this to be asynchronous and work. So we came up with some conventions, and those conventions are basically last one wins. So if you delete a file while Resharper is refactoring, it comes back, the delete is more important, and it's probably the last known good state of the file. It's deleted, so that thing wins and the file will be deleted. And the way we do that is by adding versions. So every operation that goes over the wire has a version, and if the version is newer or the same, we accept the change from the other side. If not, we revoke the change from the other side. So that's the conventions in there. We came up with our own protocol to have this view model kind of way of working there. We have Rider, we have Resharper. Rider is IntelliJ and JVM. Resharper is running on .NET or Mono. And in between, we want to have this magic protocol fixing whatever problems we have in communicating between two different ecosystems. Ideally, our developers in the different teams don't have to know about all of the details of that protocol in between the two sides. They don't have to care about state. They don't have, ideally, they don't have to care about that versioning and that conflict resolution. They just want to have that view model and add files, remove files, post inspections, etc., etc. So we came up with that Rider protocol, which is our reactive distributed communication protocol. It's open source. You can find it on GitHub. And essentially what it is a framework that works for .NET, for Kotlin, for JavaScript, and C++, or you could write your own language if you want. Basically, you're writing more or less like if you're doing gRPC, you're writing your model definition. Based on that model definition, you generate code on the .NET side as well as on the JVM side, and the protocol magically glues them together and provides you a unified protocol to work with those things and have those things communicate with one another. So it looks very complex because there's lots of layers in the diagram there, but essentially all our developers have to know is if you want to extend something in the IDE, you write something in that model, you generate the code, and you just work with it. If you're writing on the .NET side, it's going to be a collection or a string or a very simple data type. If you're on the Java side, if you're writing something in the actual UI, it's going to be a Java string or a Java list or whatever, and that's generated, and we glue it all together. The versioning, the conflict handling, and so on is handled by the lower layers, and ideally, our devs don't have to know about those lower layers. The way it works is it's socket-based. That's a very important one. So the protocol could work over a network, could work over named pipe, could work basically on every kind of wire protocol you want to plug underneath. Right. So we only have to know about those data types and creating that model. We get the code generated and so on. And the good things are, by generating that code, that we don't have anything that has to do introspection or reflection or whatever to figure out what the structure of that code is, because the code is generated in C# for the .NET side, so we just work with the C# side there. The protocol is also hierarchical and supports lifetimes. Now that sounds a bit abstract, I know, so let's go over that in a second. First of all, I want to show you how the protocol essentially works in those primitives. So it's a very simple protocol. We have a couple of interfaces. You can have a source, and a source is basically something that can fire an event on a protocol. We can have a sink, which is basically a receiver of whatever message we pass around. And then we can have a signal, which is basically a bidirectional kind of type of event that we have in there. So it's really the observer pattern. If we would create a virtual collection that is a source and a sink, whenever we would add an element to that collection, we would fire an event, and the other side would receive it as a message, and we could add it to the collection on the Java side there as well. The primitives in the protocol are those signals and properties, but also collections. We have strings in there, we have bytes in there, shorts. So all of the standard data types that you see on C# sites or on the JVM sites are pretty much supported. So devs don't really have to think about what the shape of the data is going to look like or what data type is in there. I mentioned hierarchical and lifetimes. Lifetimes, I'll cover those first, are useful for cleanup and resource management. So you all know that you have the using and the dispose pattern. So basically you have an object, you put a using statement around, and when that thing goes out of scope, you basically call .dispose and the object disappears. Now imagine you're building an IDE and you have a solution that contains projects, that contains multiple documents with editors. Every editor has multiple inspections. You already see there's a big hierarchy of all kinds of data structures that you want to clean up when, for example, you close an editor window. You want to close the editor, you want to close all of the inspections and so on. And basically having multiple using statements and manually going around and calling .dispose is not something you want to do. So we came up with the concept of lifetimes in the protocol, where we basically have this very simple class that has a stack of actions to execute whenever it's disposed. So basically, whenever we open up a new editor window, the editor window registers itself with its parent lifetime, says attach me to your lifetime, and whenever the lifetime closes, everything underneath that lifetime is also going to be closed. So we don't have to manually go around and call .dispose on everything in there. That's also open source, by the way. It's a fairly simple library, but it's quite useful in our use case. It's hierarchical in that all those lifetimes are a hierarchy. And also the hierarchy and the lifetimes are communicated over the protocol. Because on the IntelliJ side, we have a project that has a NuGet tool window that has editor tabs with inspections and languages and so on. And on the Resharper side, we have a similar structure. So if you close the editor tab, we not only want to close the entire lifetime underneath on the IntelliJ side, but also on the Resharper sides. If Resharper all of a sudden decides, okay, this refactoring has to close a certain editor tab, we also want, when we close the lifetime on the Resharper side, we also want it to be closed on the IntelliJ side there. So all of that also traverses the protocol there. Right, I'll give you a quick example because I know this is kind of abstract, so I want to give you some examples from the actual code base. So everything in the protocol starts with writing that model, and that model is written in Kotlin. Kotlin is a language on the JVM, and it looks very similar to C#, a couple of differences as well, but it's very similar. So for example, if you would look at how the NuGet host is built in Rider, so I'll quickly show you the NuGet host. So this entire tool window where you can search for NuGet packages and so on, where you can manage the package sources, look at the log of whatever operations you do in there, is defined as something in the protocol. All of the data that you see here is something that lives in the protocol. So the way it works is we have to extend our base object model in that protocol and say, okay, we have something that's going to be called the RD NuGet host, so the Rider NuGet host in there. We will have some enumerations in there, so we can say there's a conflict action which is prompt or ignore all or overwrite all and so on. And at some point we will add a sink that is called log and is an immutable list of log messages. So in our model we define that for this Rider NuGet tab where we see the log of all of the operations, that's basically going to be a collection of messages, and that's this thing in the model. So we have a sink, something that accepts data from the other sides, and that is modeled as a list of NuGet log messages that have a timestamp field, a context field, a level field, and a text field. And you also see the types of data that will be stored in there. Now, all of this is written in Kotlin in a domain-specific language modeled to our protocol, and we model whatever we want to pass around between all of the sites there. Once we figure out what our model will look like, what our view model will look like, we run that code generation, and we get actual Kotlin code that we can work with on the IntelliJ sides and C# code that we can work with on the .NET sides. So if we look on the IntelliJ sites, if I search for my RD NuGet log message, it's not finding it because it's a big solution. Awesome. You will see when we start using it that we can connect to our protocol hosts and then use that log property that we just defined in our protocol model. So this protocol model where we said we have this sync called log, this one, is converted into actual code that we can work with, and this is a collection where we say observe this collection in this lifetime, so that when this lifetime closes, when we close this solution, we're no longer interested in that subscription. Whenever you see some message added to that list that we define in the protocol, I want you to run this method called add message and do something with it. Now, this is everything the log thing or the log window does on the IntelliJ side. Basically, it subscribes to a collection, and whenever a message appears in that collection, we add it into that tool window. The more interesting thing is the Resharper side here, or the Resharper backend sides. So basically, that exact same protocol or view model that we defined in our Kotlin file is now also generated into C#. We get the exact same model, but in C#. And somewhere in that model, we will see there is something called log. There it is. So we have a log property there. That is a list of RD NuGet log messages. This is the C# side. And that RD NuGet log message is exactly what we defined in that model file. It's containing a timestamp, in this case of a datetime in the C# world. It contains the context, also defined in our view model that we have, and the text, which is a string. Now, on the Resharper side, whenever we have some operation happening in the NuGet clients, basically what we do is, again, connect to our protocol hosts, find that log property, and fire the fact that we are adding one of those log messages. And by doing this on the C# sides and having that subscription on the IntelliJ sides, magic happens and we get that message from one side to the other. So this is one thing that works in one direction. There's other things that work in different directions. So we could have a collection where we add something on the IntelliJ side and it will appear on the Resharper side and vice versa. But in this case, we wanted to log from C# into the IntelliJ frontends. I also mentioned those lifetimes, and I will show you what those look like on the .NET sites. So whenever we create the NuGet client, we also want to handle, for example, if you're using Azure DevOps, we want to handle authentication to the NuGet feeds that you want to work with. So what we do is we create a new Rider NuGet credential service, which under the hoods reuses whatever is in the NuGet client, but the NuGet client is filled with statics, and if you don't clean them up, you have a nice memory leak. So what we do is we subscribe to the current lifetime of our solution, and we say whenever the lifetime is terminated, I want you to set these values to null so that we don't have that memory leak. So this means essentially that we don't have to track the dispose method on that lifetime or on these credential handlers. It will magically be terminated whenever we close whatever we have open in our solution there because of those lifetimes. And again, it works over the protocol. So if we close it on the IntelliJ side, Resharper knows it should close that solution and project, but also that NuGet client, that credential management, etc. So I hope that kind of makes sense. I know it's sort of complicated, but really it's building the model, generating code, and subscribing and publishing messages over that protocol into that thing. All of the versioning, all of the conflict handling, and so on is handled in the protocol. Right. So it's very extensible through the Kotlin DSL that we have. So we can basically define classes, we can add primitives like strings and integers and so on. And it's really easy to work with for our developers. They can update the view model, generate code, and they're up and running. They can start working on whatever feature they are working on. A really interesting side effect of having that DSL to generate our protocol in, so you see the DSL here, is that the DSL is actual code, and our IntelliJ IDE can use navigation and code completion and so on in our model files as well, out of the box, because we're just using a programming language as a model definition and not JSON or whatever formats. So we actually have intelligence on there. We don't have to think about the multiple processes, not about state, not about that conflict resolution. It just works. It's cross-language, so it works in .NET as well as on the JVM, as well as on JavaScript and C++. So essentially, if you wanted to plug something onto Rider that is written in JavaScript, you could do so if you find the protocol connection and want to generate the code in JavaScript as well. One downside of the protocol is that writing plugins and extensions to Rider becomes more complex. So if you want to write an extension for Rider, you typically have to build something for the UI in the IntelliJ side, as well as something on the Resharper side to get your plugin up and running and get something working. We do have examples. If you're ever using the F# support in Rider, that is an open source plugin to Rider where you can actually see how that thing works, and is slightly less complex than the entirety of Rider. Same thing with the Unity plugin that we have. You can look at the sources, see what the protocol or the MVVM model looks like, what the generated code on both sides looks like, and how it all fits together. So if you want some examples, those are good ones. Right. Now, you all came here to hear me talk about microservices, and so far it's been protocol and two processes talking with one another. That's not really microservices, right? It's one product and two processes, and that's it. Well, there's a couple of interesting things that we realized while building this protocol and looking at it. First of all, Rider in itself is two processes, which means we have isolation. We even have separate garbage collection for the UI as well as the backend, because one is JVM, one is .NET, and they have their own cycles there. Each also has their own 64-bit memory space. So if the UI becomes complex and needs more memory, that's fine. Resharper is not affected by that. Same thing if you have a big solution and Resharper has to do a lot of things. The UI can be a very small process because not a lot may be needed in there. By having these two processes out of the box, we also, out of the box, have multi-core support, because if your operating system decides that the UI and Resharper should run on a different core in your machine, we have multi-core out of the box, and we can really use your CPU there. Another cool thing is that we could essentially start the two processes out of bands. They could be started independently. Actually, if you open up Rider for the first time, let's open up my second version here. If you open up Rider, and you see the welcome screen appear, so you see the splash screen appear, and then you see the welcome screen at some points. When you see this thing, we haven't started the Resharper host yet. This is pure IntelliJ, and only when you open up a solution, we actually start that second process and make that thing work. Right. If you're using debugging in Rider, we automatically create multiple processes. Basically, we have IntelliJ as the front end, Resharper as the back end. Your application that you want to debug is also running, but we also start a separate debugger worker. Whenever you want to debug, we start an additional process that attaches to your process and that we attach to as well to get the information about breakpoints and value states and so on that you have in the memory space of that thing. The reason for that is, first of all, it's kind of nice because you get nice separation and isolation of the code there. But second of all, if for some reason your application crashes or makes the debugger crash, you don't take the entire Resharper host down. Your debugging session will stop, but everything else will still be working. We don't crash your entire working environment if the debugger fails in this case. So we get 4 processes for debugging. We thought, okay, well, we have this for debugging out of the box now. What if we could do certain features as a separate process? If you do WPF, basically, not everyone is continuously working on the UI in their WPF application. We only need to run the designer or the previewer whenever you are actually doing WPF or whenever you are doing WinForms and so on. So we could launch that preview window that you see where you see the preview of whatever XAML code you are writing. We only start that process rendering that preview whenever you open up a XAML file. So we don't run it all the time. Again, if you have some invalid XAML and that process crashes, that's fine for that process, but the rest of Rider doesn't really care because it's a separate process that can fail independently from the rest in there. Another cool thing is because we have that shared view model, those additional processes can also contribute to that view model. So I don't know if anyone using Rider has ever seen that there's also Roslyn analyzers supported in there. What we do is whenever we discover you have Roslyn analyzers referenced in your C# project, we start a separate process that runs all of the Roslyn inspections on top of your code and contributes the inspections back to the protocol by just adding a name, an icon, severity, tooltip, and a text range. So again, that simple data format that we have in there, but it's a third process basically contributing that to the same view model. So the protocol is the view model, and we just add things in there so that they work across the boards. And this is basically what it looks like if you look at the processes there. If you have something that has Roslyn inspections, you will see that in the UI as well whenever something is there, and you will see a separate process running that thing in your Process Explorer. If you don't have Roslyn analyzers, we don't start that process because it doesn't really make sense to run it in that case. Another cool thing, since the protocol is socket-based, we could run the protocol across machines, and that's especially handy when you're using Docker and you want to debug your Docker container. In fact, that's really a different sort of machine that you are using, that Docker container. So we could run our debugger process inside of the container and then set up a socket connection with Rider to get the information when you debug an application that is running in that container. So Docker debugging works like this, and remote debugging works like this as well. The Unity game engine, anyone here ever developed something with Unity? Okay, cool, a couple of people. We have an extension to our view model that also supports the Unity editor, and basically what we have is that Unity extension plugs into the IntelliJ side, plugs into the Rider or in the Resharper side of Rider, but it also plugs into the actual Unity editor. So basically what we can do is have our view model across 3 different types of processes, across 3 different types of IDEs basically. And that allows us to do really cool things. I'll quickly show you a video. So this is Rider, and in Rider, of course, you can do a find usages of a certain button in this case. So if we do a find usages, what we can do is publish on our protocol the fact that we want to find usages, and all of a sudden we can magically make the Unity editor appear, which is a separate process that we don't really control apart from our plugin in there, and find the usage of where you have a button event handler on that thing. So we can even work across different types of applications if we have a plugin in there. That's kind of cool to do. Right. Now, that brings me to the future. So this is what Rider is currently and what the protocol offers currently. Now, the fact that we can run this thing on multiple machines, the fact that it is socket-based and so on, sort of gave us some ideas to build on top of that protocol. One of the things we want to do and are actually doing for a lot of the new features right now is build our UIs as a model in that protocol as well. So if you ever go to the options in Rider, you will see this tool window for configuring C# Interactive, for example. That is code where we basically add UI onto our protocol in a list, basically in that protocol to render that UI. The cool thing about this is that since Resharper is also still a plugin to Visual Studio, we can reuse the same view definition that we have in code there to also render that UI in Visual Studio if we wanted to. So we can start sharing the UI between two separate products as well if we wanted to. So that is in active work. So we're actually using this today. Now, some things that we are thinking about and experimenting with and having fun with is things like really making use of the fact that we can run the protocol on multiple machines. Imagine you are using a Mac for your day-to-day developments, but you have to work on a WPF application. Most people will not want to have a virtual machine just to have WPF working. Well, maybe we could run part of the protocol on a Windows machine to render your WPF preview there, and you can still develop it on a Mac. That's one of the things that we are experimenting and playing with. Another thing could be that we could run IntelliJ, the front end, on one machine and have Resharper running on some other machine and just communicate over the network. In fact, I saw a demo of some of our team members a couple of weeks ago where they were using the protocol to share the Resharper caches across multiple machines using the protocol. So you know, if you have a very big solution, Rider has to index everything in there and make sure that it knows how everything fits together. Well, why not share that information using the protocol across multiple developers even? So that's one thing we're playing with as well. And a very crazy idea, I don't think this is going to happen anytime soon, but I've seen some prototypes there, is that what if we could make every of our IDEs something that uses the protocol and exposes the protocol so they can contribute features to one another. Right now, if you use Resharper in Visual Studio, we have our own TypeScript implementation in Resharper and in Visual Studio. But if you're using WebStorm, we also have a TypeScript implementation in there. What if we could, at some point, expose WebStorm as a protocol contributor and remove everything from Resharper in terms of TypeScript and simply use WebStorm as the TypeScript engine in Resharper? That's also a very cool idea. Again, this is going to be a lot of work for us if we ever want to do this, but this is our current line of thinking. Maybe we can reuse whatever we already have in there. It could even be, and that's a really cool idea that some of the devs came up with, what if we could use Visual Studio to power some of the features in WebStorm, for example, so vice versa. And yeah, again, it's not going to happen soon, but it's a cool idea, I think. So with that, in summary, I don't think a lot of this talk is going to apply to your day-to-day work, although I hope that some of the concepts that we have in terms of the MVVM model there are maybe something that you can apply in your own projects. But I did want to give you a peek into how we came about building Rider, how it is built, and how those two things work together, and basically how starting to work on this IDE and making sure two different languages, two different JVM and .NET could work with one another, how that basically gave us a glimpse into the future of what Rider could become over the next years. So we have a rich and easy programming model there that the developers really like. They only have to build the model, generate some code, and it automatically works with everything that we discussed here. And having everything sockets-based and a view model that can be shared across multiple processes is really interesting for the future. So with that, thank you for being here. And if you have any questions, feel free to ask them. Thanks.